So in this video, we're going to be looking at your local extremes. So your local extremes, they basically just want you to tell them where is our graph at maximum or where is our graph at minimum. So you know here you definitely have your maximum, your minimum, and here you're going to have your maximum. So those are some of the things that they want you to tell them. So what I would advise is that whenever you get this question, the first thing that you have to do is to write down the domain for this one so that you won't make any mistakes. So if you're writing a domain for a function that looks like this, so you're going to do it into two separate parts because you are now controlled by this sign in between, which is a negative. So you're going to be looking at them like this. You look for the restriction for each individually, and after looking for the restriction for each individually, you then come up with an answer that will work for the two combined. So now we have to ask ourselves that what is the domain of 2x? Where is 2x breaking, or where is 2x being undefined if we're having numbers between minus infinity to positive infinity? For example, we can just assume we are working with minus 3 to 3. If we input these values between minus 3 to 3, they are all going to give us an output, whether negative or positive. That's still an output. But when we come to this one and we try to put something like your negative 3 or your negative 1, this actually becomes undefined. So it basically means for this one, your x should be greater than or equals to 0, because when you are putting 0 in here, your square root of 0 is 0. Then your square root of 1 is going to give you something else, as long as it's not giving you an undefined answer or breaking. So since this one we're saying it's going to be it's greater than or equals to 0, then we also have to work out for this one. This one we said all the answers are giving you a positive or a negative output, so we can just say x is the element of all real number lines. Okay, this one supports all the values there are or there is on the number line, but this one doesn't. This one strictly starts at 0 and includes 0 up to positive infinity. So where can we look for the intersection between these two? Since this one allows all the answers, and since this one only starts from 0, we can finalize by saying the final domain that we will take. We will say that our x is such that our x should be greater than or equals to 0. This is in set notation. So now this domain that we've written, it does satisfy both of these. So now we have to do what? We have to try and write the second derivative for that function. We have it like this. Remember, as I said, or in the last video where I was doing the first derivative test, I had a table that looks like this. You know, in here we can have our first derivatives, then here we have our second derivative. Then how would they ask your questions in this one? You can have some things like your local extremes. They can ask you where the graph is increasing or decreasing. Then lastly, they can ask you to determine your critical points. Then in here they will tell you something like your inflection points. Then they will ask you where your graph is concave, up or down. Then they will ask you to do second derivative test. In here they will ask you to do your first derivative test. So in each of any of these cases, that's when you're going to use the first derivative. In here you're going to use the second derivative, because these are also some of the questions that they could ask you in your multiple choice questions. They give you a function and ask you to determine those. So that's one thing also that you have to remember. So now we have this, but this can be expanded and written as your 2x minus your x. We can have 1 over 2. I didn't change anything, I just rewrote it like that. But now we have to write the first derivative of this. We will say our first derivative will look something like, you will have your 2 minus 1 over 2 is going to come here. We have 1 over 2x. Then 1 over 2 minus 1 is still going to be 1 over 2. Then we're going to have 2 minus 1 over 2. Then remember here we're having multiply actually. We can say this one, x to the exponent minus 1 over 2 can be written as 1 over root of x. So to finalize this one, we will have 2 minus 1 over 2 root of x. Remember this is over 1, and if it's over 1, it means now we can just say at the bottom we have 2 root of x. Then now we just multiplying throughout. This multiply by that one, we're going to have this multiply by that, we're going to have 4 root of x. Then this multiply by this, it's going to give us minus 1. So now we're working with a part that looks like this. That would be the final part that you have to work with. So each and every time you get a fraction that looks like this, remember that you have to work out the two parts separately, the bottom, the top and the bottom. So you're going to work the two parts separately. So let's say in here you're going to have your 4 root of x minus 1. Then the other side you're going to be having your 2 root of x equals to 0. So in this instance, what are we doing? We're basically determining the critical points. So we're working out those critical points. In here we're having our f of x is equals to 0. In this side we're just determining the side which can be undefined. So we're having this would be equals to 0. So we will have 4 root of x. We take this minus 1 to the other side, we'll have 1. Then we divide by 4. We're left with root of x is equals to 1 over 4. Then to remove this square root, we'll just have to square everything up. Then we'll say we have our x being equals to 1 over 16. See, so in this side we're going to just divide by 2, then your root of x will be equals to 0. Then we square everything, we're left with x is equals to 0. So now that we've worked the two parts, we're supposed to now go to the last part, which is your number line. So your number line is going to be like that. Then here you have your 0, here you have your 1 over 16. Actually they're just too close, because this one, I think the last I checked, it was 0.06 or something. You see, so I'm just writing it at least a little bit fast so that I can have some space to operate. So what I also like to write, I like to write this just to show that I'm going to be doing my testing on my first derivative, because I know some students make the mistake of testing using the original function. So just note, when you're testing in your original function, you're actually finding your y values. So always test in your first derivative. So now you see the part where I was saying why you should make it a habit that you write your domain. You see now this part from here going there, this is the one that we are not going to consider because of our restriction that we have here. So we're only going to be working with the part going there, meaning I can just erase that one. But even if you don't erase it and still write it, it's fine, it's fine. But the only thing that you need to test, you only have to test here and here. It's not really necessarily to test here. So you're going to look for a number between 0 and 1 over 16, between 0 and 0 0.06. You can use 0 0.01 or 2 and input that one into this, or a one that is simpler to work. I don't know, even if you prefer this one or this one, it's fine. It is just a matter of which one it's simplified even further. So you will see that whatever answer that you're going to get, it's going to be negative here. Then on that side, between your 0.06 and any number, it could be 100 or up to positive infinity, it's going to give you a positive number. You see, so since this one, since you are only working from here to here, I would just come and write dotted lines between this one, like this. Then now I start interpreting these two signs that I have. That a negative, it's what? Remember, we have our concave up and concave down. These are basically your local extremes. This, it's your local minimum. Then this would be your local max. So this would be that dotted line I'm doing. Then your negative, it's just something that is going like this. Then your positive, it's going up. So now you have a shape that looks like this. So it basically tells you that at your x is equals to 1 over 16, we have our local maximum. Because the last step that you have to do is to do your conclusion. You will say we have our local maximum, and the local maximum value is, you're going to take this x is equals to 1 over 16 and input it into the original function. Because there is another way that they would trick you in an MCQ, multiple choice questions. They like to ask this in a way that they would give you this value as one of the local maximum, but if the wording says a the local maximum value, always input this local max into the original function and find that value that they are referring to. I think it's, yeah, it's your f into 1 over 16, then it's going to give you minus 1 over 8. This is the local maximum value. But if when they ask you what is your local max, you're going to say it's this one, but your value is going to be this one. So that's basically how you do your local extremes. So I'll see you in the next video.